Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, find the values of x and y in the diagram. So we have that x is an angle in this triangle on the right, and y is an angle in the triangle on the left. Now, we are given some tick marks, and we're given a right angle box, so we're given lots of stuff. This is great. Now, let's look at x first, which means let's look at this triangle on the right first. Okay. Let's look at this triangle on the right first. So, all the sides are congruent. That means that I have an equilateral triangle. If I have an equilateral triangle, then I have an equiangular triangle. So we know that all the angles are the same in this triangle on the right, which means x must be equal to 60 degrees. The only way that you can have the angles be all congruent and add up to 180 degrees is if the angles are 60 degrees. So x is 60. Now y. What about angle y? Well, first I notice that we have two congruent sides in the triangle on the left, which means we have an isosceles triangle, which means the base angles must be congruent. So the two skinny angles, the one on the top and the one on the bottom left, have to be congruent. Now, I can't find y until I figure out what these angles are. But I know that this whole angle down on the right is a 90-degree angle. And if I know that part of it is 60, I can figure out what the other part of it is. That's 90 minus 60, which is 30 degrees. So this small angle on either side is 30 degrees. Both of them are 30 degrees because we have an isosceles triangle. Now, if both of them are 30 degrees, I know that all the angles in a triangle add up to 180. So I just need 30 plus 30 plus the measure of angle y equals 180 degrees. So we'll subtract 60 from both sides, since 30 plus 30 is 60. And that gives us that y is equal to 120 degrees. Y is equal to 120 degrees. So we found x and we found y. And another thing I'll point out, we used everything that they told us, all the information that we were given in this diagram, we used. We used the fact that this was an equilateral triangle. We used the fact that this was an isosceles triangle. And we used the fact that there was a 90-degree angle in the bottom left corner. So, when in doubt, if they give you information, you're probably going to need to use it. Okay, that was a review from 5.4. Now, let's jump into what we have for today. Now today, remember I've said we're going to do 5.4 before 5.3, so I know we just finished 5.4, but now we're going to jump into section 5.3, which is proving triangle congruence by SAS. We're going to talk more about what SAS means in a little bit, but the reason that we put 5.3 after 5.4 was because 5.3, 5.5, and 5.6 are all about proving triangle congruence by, and then they have a different acronym at the end. So I put them all together so that we can prove triangle congruence all at once with 5.3, 5.5, and 5.6. So, our learning target for today is you know what the SAS Congruence Theorem is, And the success criteria is that you can use the SAS Congruence Theorem to solve problems. Now, before we talk about the SAS Congruence Theorem, it's going to be important to review what congruent figures are. So, congruent figures are geometric figures that have the same size and the same shape. So not only does the shape have to be the exact same, but the size has to be the exact same too. Now, another thing that I want to tell you is that the shape of the figures is determined by the angles, right? If the angle is wider, if it's smaller, that's what determines the shape. What determines the size is the lengths of our sides, or side lengths. If these side lengths are longer, I have a bigger triangle. But if the side lengths are exactly the same, then they'll have the same size. So remember that congruent figures have the same angles and the same sides. The angles are congruent, so angles are congruent, and the side lengths are the same, or the sides are congruent. So sides are congruent, angles are congruent. That's what it means for two figures to be congruent. Okay, now, let's get into what this whole lesson is about. The learning target and the success criteria were both about the SAS Congruence Theorem. SAS stands for side, angle, side. Side, angle, side. And what this says is if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So remember, in section 5.2, we talked about if all the angles are congruent to all the sides, then the triangles are congruent. But we actually don't need all of the sides and all of the angles to be congruent to know that the triangles are congruent. If I have two sides and the included angle, that means the angle in between the sides. The included angle is the one in between the two sides. So if two sides and the included angle of one triangle are the same as two sides and the included angle of another triangle, then we know all the other angles are going to be the same, and we know that all the other sides are going to be the same. We know these triangles will be congruent just by knowing side, angle, side. Now remember that these sides will be congruent, but we don't need to be told that. If we see a diagram that looks like this, two sides and the included angle of both triangles are congruent, it means that these triangles must be congruent. Okay, now let's do some examples. Now we know what the SAS Congruence Theorem is, but we need to be able to use it to solve problems. So, I would encourage you to rewrite this theorem in your own words. Test your understanding of the learning target. Do you really know what the SAS Congruence Theorem says? If yes, awesome, you're ready to move on. If not, make sure that you understand this theorem. Otherwise, the problems that we're about to do are going to be a little bit trickier. Okay, all right, our first example of the day is about included angles. It's very important that you understand what an included angle is, because this theorem, the side angle side theorem, hinges on two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle. So, it's very important that we understand included angles. So, our first example is all about them. And let's color code. I'm going to do the first one in red. We are asked to name the included angle between the pair of sides given. Okay, so I am given AB and BD. AB is right here, and BD is right here. I want the included angle. The included angle is the one that connects the two sides, the one that is in between the two sides. This angle, angle A, isn't in between the two sides. It's only touching side AB. And this angle, angle ADB, is only touching side BD. So we need the angle that touches both sides and the angle that is in between them. So this is angle ABD. Remember, we can't just say angle B, because which angle B are you talking about? This one? This one? This one? We don't know what angle you're talking about if you say angle B. So you need to be very specific and say angle ABD. All right, we'll do the next one in yellow. Side DB, and BC. Okay, so here are my two sides. I want the included angle. Can you name it? Before I even name it, can you name it? Well, remember, it's the angle that connects the two sides, the angle in between the two sides. So, this is angle DBC. And we could have also named it CBD. That would have been fine also. Whichever way you named it is fine. You notice a pattern between AB, BD, ABD, DB, BC, DBC. You notice a pattern? Why might that pattern be happening? Think about it. Think about why might that pattern be happening. Okay, we'll color code again, different color this time. Now we have DA and AB. So DA is right here, and AB is right here. Now, the included angle is the one that connects the two sides. So, we could just call this angle A, because this is the only angle A. We also, if we wanted to get more specific, we could call this angle DAB. Oh, so tempting, so tempting. Angle DAB. Okay. And check out that pattern. All right, I want you to try the last one on your own. Pause the video, try the last one on your own, and then unpause it to do it with me. Okay, we have side BD, which is right here, and side DC, which is right here. We want the included angle, which is the one between them. So that is angle BDC. And if you said CDB, that also would have been correct. Remember, it doesn't matter. As long as the vertex is in the middle, doesn't matter the order of the two on the outside. Okay, wonderful, wonderful. Beautiful. That is our first example. Let's go ahead and move on to the second example. We're going to crank up the difficulty just a little bit. Example 2 is about determining congruence using side, angle, side. So we are asked to decide whether enough information is given to prove that the triangles are congruent using the SAS Congruence Theorem. So, do the two triangles have side, angle, side? Are two sides and the included angle congruent in both triangles? If so, yes, They are congruent, and we know because of the SAS Congruence Theorem. If not, darn it, they're not congruent. We don't know. There's not enough information to prove if they're congruent or not. So, let's look at the first picture here, the first set of triangles. We're told that these two sides are congruent, BC and DC. These sides are congruent. And we're told that AC and EC are congruent. So we have side, 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 side here. But in order to have side, angle, side, we would need these two angles in the middle to be congruent. Then we would have side, angle, side, side, angle, side. But right now we just have side, side, which isn't enough. So, is there any way of knowing if these two angles are congruent? What do you think? Do we know that these two angles are congruent or no? Remember that these angles are vertical angles. Remember when we have two lines that cross, the angles on the opposite sides of those two lines are vertical angles, and vertical angles are congruent. So yes, we do have enough information. Yes, for the first picture, enough information is given to prove that the triangles are congruent, because we know that vertical angles are congruent. Wonderful. All right, I'm going to get a new color, and let's look at the second diagram. Now, we are looking at these two triangles. And in fact, let's name them. We're looking at triangle ABC and triangle, let's see, we have to go in the same order, ABC and CDA. ABC, CDA. Okay. And we want to know, is there enough information to prove that these triangles are congruent? Well, we're told that side AB is congruent to side DC, and I want you to notice something else. Both the triangles share this side. Now, if you and your sister share a water bottle, you have the same water bottle. You have congruent water bottles because you have the same water bottle. If these triangles share a side, that side is congruent to itself. This pen is congruent to itself. Anything is congruent to itself. So, we already know. We can say that this side that they share, it's congruent to itself. So we can put these tick marks here. Now, we have side, side again, but, we would need, right, side, angle, side. We would need the included angle to be congruent. Do we know, is angle 1 congruent to angle 2? Do we know that? Well, what do these arrows mean in the diagram? Remember that if the diagram gives us information, we probably need to use it. But we haven't used these arrows yet. What do these arrows mean? That's right. It means that the lines are parallel. So we know that side AB and CD, we know that they're parallel. And hey, if these lines are parallel, that means that AC could act like a transversal. Remember your chapter 3. So angle 1 and angle 2, these would be alternate interior angles. If the lines are parallel, then alternate interior angles are congruent. So yes, we do know that angle 1 and angle 2 are congruent. We know that because the lines are parallel. So angle 1 is congruent to angle 2 because they are alternate interior angles. Which means that, hey, we have side, angle, side, and we have side, angle, side. So, yes, there is enough information to prove that the two triangles are congruent using the side, angle, side congruence theorem. Now, one thing I want to point out before we move on is you might need to look at the diagram a little bit closer. So it says decide whether enough information is given. If we just looked at this, we'd say, well, no, there's only two sides, there's no angle. But if we looked closer, we saw that there were actually vertical angles there. And in this diagram, we had to see, they share this side. There are alternate interior angles. So you might need to look a little bit closer at your diagram to make sure that you can't deduce any more information from the diagram before you determine, yes, we can prove it, or no, we can't prove it. Alrighty, let's go ahead and move on to our last example for today. Using side, angle, side, and properties of shapes. So, in the diagram, QS and RP pass through the center M of the circle. What can you conclude about triangle MRS and triangle MPQ? What can we conclude? Well, first thing, and I'm going to color code. First thing I notice is we have vertical angles. So we know angle SMR is congruent to angle QMP because they're vertical angles. Because they're vertical angles, and vertical angles are congruent. Now, let me get a different color. In fact, we'll go back to purple. QS passes through the center of the circle. Remember that every point on the outside of the circle is the same distance away from the center. That's the definition of a circle, is that every point on the outside of the circle is the same distance away from the center. And that distance is the length of the radius. So if this were, I don't know, say 5 inches, every point on the outside of this circle is 5 inches away from the center. So every point on the outside of our circle is the same distance away from the center. So R, S, P, and Q are all the same distance away from the center. And now, okay, that tells us that SM is congruent to QM and PM is congruent to RM, which means, look at this, I'm going to get a different color. We have side, angle, side, side, angle, side. That muddied up the diagram a little bit. But if I take these triangles out, SMR and MPQ, we have these markings on our triangles. So I just drew the triangles inside of this diagram. I drew them down here so that it'd be easier to see outside of the circle. So, because they have two sides and the included angle are congruent, we can conclude that triangle MRS is congruent to triangle MPQ. Because of the side angle side, we should write that, because of the side angle side congruence theorem. Okay, and you know what? I'll write the reason over here too. We knew that the sides were congruent because of the definition of a circle. That's what a circle is. That's what it means to be a circle, is that every point is the same distance away from the center. Yay! Okay. We can check and make sure that we were correct. Because they are vertical angles, angle PMQ and RMS are congruent. All points on a circle are the same distance from the center. So MP, MQ, MR, and MS are all congruent. So triangle MRS and triangle MPQ are congruent by the SAS Congruence Theorem. And we were correct. Booyah. Okay. That is all I have for you today. What I would like you to do right now is check your understanding of the learning target and the success criteria. Do you know what the SAS Congruence Theorem states? And can you use it to solve problems? Rate yourself 1 out of 3. Are you feeling awful, or are you feeling like you are ready to crush the homework? How are you feeling? And if you're less than a 2, definitely check in with a teacher, talk to a friend. And if you're greater than a 2, you're ready to start practicing the homework, and hopefully that will take you all the way up to a 3 once you finish the homework. Speaking of homework, these problems might not be the problems that your teacher has assigned for homework, but they will help you test your understanding of what you have learned in this lesson. So these problems are like example 1, 9 through 14 are like example 2, and these last 4 are like example 3. So you can test your understanding of all the examples we talked about in this video. Now, the last thing that we're going to do, as usual, is let's end our video with a launch, shall we? This launch comes from an anonymous person, unknown. It is unknown who coined this phrase, but the launch is, wherever life plants you, bloom with grace. Now, there's multiple parts to this launch. Wherever life plants you, no matter where life plants you, you can bloom. It's your choice to bloom. You can choose to bloom, or you can choose to be, you can choose to not bloom. It's totally up to you. So no matter where life puts you, no matter where you end up, you can bloom. You have the choice, you have the opportunity to bloom. Now, bloom with grace. You can bloom all over the haters and rub it in their face, or you can bloom with grace. And you can say, you know what? I worked very hard to bloom this way. I worked very hard to get where I'm at, and I'm thankful for everything that made it possible. When you can, choose grace. And you always can. Choose grace. Choose to be graceful in the way that you bloom. Don't make other people feel bad about your blooming, because everybody should bloom. Well, everybody wants to bloom, and everybody should get the opportunity to bloom. So don't put other people down with your blooming. Encourage other people to bloom with your blooming. So, and of course, bloom could look like, being successful, whatever success means to you, and being happy in life. And that's what we want for everybody. So you can bloom, the choice is yours, but make sure that you're blooming with grace. So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.